Hi, I'm Tom Fetherston. I'm going to give a talk on regular expressions, specifically how I think of them, what my mental model is, and hopefully that'll give you a leg up. I'm also going to show a kind of general domain-specific language called simple regular expression language. And it takes away some of the the special characters and that sort of thing that you get in a particular instance of regular expressions. So let me start with a question. Anybody have a guess to what this is? A hint. Oh, it's a specific kind of object. Well, this is a model for strings, because I've got to communicate my model to you. I've got to use some audio visuals. So this is where the string would be. This is specifically an empty string at the moment. So it might be a string or a string. And since we're doing Python, it might even be a string. Now, this model was going to be more involved, but unfortunately, I got to start with this talk with a public service announcement. Don't mess with table saws late at night. So this model is supposed to have little tiles to represent the characters in the string that I'd be demonstrating. That's where I went wrong. Big sheet of hardboard that I was going to laser all the letters out and make that. So I'm going to explain with some paper what this would have been, and hopefully will be, because I'd actually like to give this talk at PyCon next year. So think of it as something that is going to evolve a little bit. Just a note, I have my notebook up at my GitHub site. Got a 4-letter GitHub. You can tell I was early in on that. Tfer. And if anybody's set to run the notebook and wants to, they can download this now, and we can run it and we can go along. If not, there's more information in here than I'm going to be able to get through. It's not in the final format, too, because I didn't get a chance to polish it as much as they wanted to. But remember this and download it, and if you'd like it, check it a few times, because this is going to evolve some more over time. Okay, to go to this model, this top rail is where the regular expression would be built up. And the bottom rail is for the string, as I said. So what it was going to be, and there were going to be like position numbers and that sort of thing, but what is going to be a sheet of thin plywood with a letter on it, and the letter was going to be out of hardboard, the brown stuff. And it's important for the model because it would then have some dimension here, and so it would be sticking up just a little bit. Now, I talk about in this notebook, guess I've got time out on that. I'm going to one thing about Python and regular expressions in general, they use character about 8 different ways when they're talking about them. It's way too confusing, it's way too much. And for this model, instead of character, like in the documentation, I use it frame instead. And frame pretty much in the sense of a picture frame. So think of this as raised. You can see that a frame would match a tile, would match any character. No matter what was there, you could put that down over it. Now, inside the frame, and this was going to have a darn static electricity. So at a frame, it has glass over your picture. So I was going to laser cut out that, which would leave me a negative. And, some letters have pieces in the middle of it. But you see, for a specific letter in this model, the glass would allow it to go over and, be locked in over the tile. So by locked in, it's kind of important for the model. You kind of think of this as sliding over. Here's next. We're looking for next. We've got to match. Click. And it's locked there. And then we could go up and deal with the next thing from our regular expression to see if it made a match. Now, if it didn't, in trying to, go over the next tile, since it's raised and they weren't sinking, it wouldn't be able to cover that letter, and in the process, it would cause the frame, and you can think of this maybe as a speck, it would cause this edge to lift up and release your sink. You're satisfying that portion of the regular expression. Once it wasn't made anymore, this is free to slide again. And you can think of this as having a spring or something. It's just got a natural tendency to go further on in the string. So when it meant the next character that is satisfied that portion you're looking for, if there's more before it would lock it all the way back. So you would again be free to go and make the next instance of that character and then continue to test through your regular expression. So you could think of, like I said, this would be where the regular expression where we want to find would be, you would have a portion of you bring down, but see if you can make any of that to lock it in, and then you reach another portion and see if that goes. If it did, you could again continue on. If it didn't, it would unlock everything and let it continue to slide and hit the next expression. So that's kind of what this model was supposed to represent. You could think of each subquery kind of taped it all together. So I kind of thinking of it rolled up so I can see what's coming up, and okay, got a lock. Let's see if the next one here will go. It did. Next one here will go. It did. Next one here to go. Okay, the whole thing's satisfied. I found A, B, C. Say I was looking for that. Now, what if it was case insensitive? How would I handle that in this model? Well, I don't have an example of that, but let's say if we were looking for A, lowercase a, and there was a case insensitive switch on it, then I would have A cut out lowercase and an A cut out uppercase. so that it can match both the lowercase and the uppercase and be case insensitive. Now, there are other things that we should talk about. Another part of the model that you need. You run into something that's generally called in regular expressions a character class. And that is like a selection of letters. Okay, I can match it. Like specifically, you're listing like a set of maybe 3 characters. You want to match open parentheses or a bracket, square bracket. You put those characters in the character class, and then you could think of that as like a loop. So that you would pull down into the frame. Okay, does it match that? No. Check the next one. Does it match that? No. Check the next one. So you've gone all the way through the character class. And if you've got a match, that would lock in. You go to the next portion of the regular expression. If you didn't match, again, it would unlock the sequence and it would start selecting again, looking for the next instance you could match. Okay, there's another distinction I want to make. And this model kind of points out well. When you're looking for regular expressions, you're actually trying to match one of 2 things. In this model, you're actually trying to match a tile, but there are also entities they call anchors. And when you're matching an anchor, what you're actually doing is you're looking for the space in between 2 letters, or 2 tiles in this model. And that's where you would start your regular expression with something. And if you make it the condition that the anchor is looking for, it kind of like inserts a thin, plastic again, into that space there, and then goes down and see if it can match tiles. It also can be at the end of expressions, these anchors. Say if you're matching a word boundary, it would look for that slot. And the properties of those slots actually depend on the character before and the character after, because you're actually looking for a transition. If you're looking for word boundaries, you're looking for a transition from space to tile. That specifically alphabetic. They call it character. Why they do that, I don't know. It's really because there are things that wouldn't consider a character in a word. More properly, it's looking for an identifier, and that's as a particular character class. It's kind of language specific, but in Python, it's an exact match for what they consider an identifier. Alphanumeric, so either an alphabet character or a number, a digit, and it takes the case of underscore. So that's how you make up identifiers in Python. And so if you're matching words in Python, that's a good definition, because it'll match regular words, like in the comments, it'll match identifiers with, dunder in each side, because underscore's there, and the convention separating words with an underscore and having letters and numbers, that's part of it, is the definition. So word boundaries, anchors it can do. And there are all sorts of special cases, of course. I said white space before, white space after. But what if it's at the beginning of the slot we're looking for is at the beginning of the string? If it was at the beginning of the string, you can consider that kind of the same as white space, so it could match there. Because actually there are anchors for the beginning of your string and your end of your string. Sometimes you want your regular expression to match the entire, well, string. So you can match there, you can match there. You can consider this white space. And again, special cases. Another thing it can match, if there was a new line at the end of our string, which there might well be, it would match there too. If we consider that the end of the string, even though it's not, because you can have a new line at the end. So all these special cases, I tell you. And then the nice thing of having the, dead again. But the nice thing of having in a Python notebook like this, who here has used Python notebooks? Let me ask. It's good. I mean, the good thing about this is that you can like play with those special cases. It's like, okay, does it see that? Oh, no, it doesn't. Or yes, it does. Like I would specifically did a new line to see what it would do. Because, you know, you just think of these things. There's so many special cases. So you play with that. Okay. So that's the two general things that could start a match or end a match. Anchors, again. And you might just look for a general letter to start your match. And if that's the case, you know, that could occur any place in a word, say. So it can be partly through a word and match that, which may or may not be what you intend. So that would, like, they often use validating email addresses. You can have a valid email address inside of an invalid email address. So if you don't check for start of string, it would come back, oh yeah, good. And it wouldn't be. So just things to become cognizant of. All right. That's interesting. It's on that screen, but since we're dead, well, it doesn't matter. I don't even need my glasses with this one anyway. Okay, so this notebook starts out with a cell, that's not the way notebook works, that checks for the presence of this Python module called SRL. And, you know, I'm using Anaconda for my distribution. So it's not in the Anaconda distribution. This first cell will check for is this module present? And if it isn't, it'll pip install it. Now let's execute this. And you see here, it's already present because I've executed this. And this is kind of distribution dependent because you don't know what kernel you're running, but this will check what kernel you are running for the notebook and install it to that kernel. Okay, so let's just start the presentation. Now, as I said, simple Regex language is just what they call a domain-specific language. You know, it's just a short little thing that's made up and addresses a small problem. And the problem it's addressing is like, oh God, the characters they use, they're crazy. And how they use them is crazy, and each language does it slightly different. So how are you going to think about this? And that's kind of important for this reason. You might think, I just use Python. That's the only syntax I have to know. Well, how much your editor, who uses VS Code to do the Python editing, or Atom, or any of the other editors, some of the ancient ones, Vim, Emacs, they all have their own, or the languages that are written in module that does the regular expressions in that. So you may be searching for something and need the regular expression of Java for Atom and VS Code because they're written in Java. So that's just the regex search engine that those use, and it's not Python. There are differences in the syntax. And this abstracts away those, and there are online places where you can like test it and request whatever language you want for that, what you're trying to search for, and get it. And so anyway, there are a few general notes about the language here. The big ones is we call it SOR. I love abbreviation. Sorry, it's like jargony, but SOR is case insensitive. That means that the keyword can be written uppercase, lowercase, mixed. It doesn't matter. It doesn't mean that strings that are part of the language will be case insensitive. They'll only be insensitive if you tell it, oh, I'm going to put a flag at the end that is case insensitive. So the strings will match. That's what they're saying, this burst point. Test, the string test in uppercase is not the same in this language as the string test lowercase. All right. That's probably the biggest point from that. So here again is with the first use of character. They just call this character. And that's kind of the first, like, character. Well, I know what a character is, and that's not it. In this case, I use frame, like for my model. So, talk about that here. Okay. So, again, I have to resurrect character. A lot of the keywords and this small language involve what I'm calling character set names. Now, by that, I mean they're trying to describe a set of characters, trying to reduce what you look at. So they don't make that distinction either. So the first one is kind of a stretch for being, in this class. It's the keyword literally. So literally means the string that follows. That's what I'm going to be searching for, letter by letter, in my regular expression. So literally string without any flags means here, it means I'm looking for just the word string. And we'll build up Regex by composing this. It's actually kind of a combo, because it could be literally S, literally T, literally R. It was kind of the way, according to this language, it should be written, but this shortcut wants to type 20 lines. just to do that. So I have an example here. We're going to search literally for sample. And the SRL module, we imported this object in that first cell, SRL uppercase. And that's what we feed our strings to get the result back in Python syntax. So let me execute this cell, see what we get. Okay, here's like the first instance of the weird characters. If I went to go, oh, geez, okay. Not going to get through that much of this, which is okay. Like I said, this is online and you can look at it. So I'll speed this up. So this is what you get back. This is actually from Perl 5. It's a convention that was added to Python. They did it this way because question mark after any parentheses, it would be an error in the previous regular expression. So they trapped that error and extended the regular expression. And so that means literally string. Okay, this is the way to build up a character set using one of. So in this example, we're looking for, like I said, in my model, it would be a vertical A, vertical B, a vertical C that you would slide into the frame to match, test. And so this is what it would return when we feed it. So, and this is another thing that you run into in any regular language, escape sequences. We often use characters in a special way, so they have to be escape. One of the way we introduce special characters is with a backslash. Again, I like abbreviations. I call it a blash. Anything I can reduce to one syllable, I do. That's the way my brain works. So we need a blash there. It's not because we want to make a special expression. We just want to, it considers the percent sign one of its special characters it needs. So it's got to escape that in the sense of, oh, I just want that regular letter. That's why I wrote a test in there to compare that what I'm getting returned if you enter in a raw string, which is a nice thing about Python that like gets you around the fact of having to throw in all these gobs of extra blashes to escape or to end up with what you want. You can just put it there. So I'm testing that and that. So then this character set is kind of simple. Is it a letter, or is a more restricted set of that would be uppercase letter. So that it kind of breaks down in like you would have to have a vertical strip A, B, C, D all the way to Z, upper and lowercase, or if I was using the keyword uppercase, just A to Z in that vertical strip. So that, or it could be superimposed like we did uppercase and lowercase, but that would be really complex. And there's another refinements model that I won't go into that deals with that. But you can still think of it as meaning that. So let's skip down to there, like any character. Oh my God, here's character again. And it doesn't even mean what you think it means. This is again, that it should be any identifier that would be closer to what they're intending here. So, and it has no character. So that means any character that isn't in the set of alphabetic, numeric, or underscore, this would be a match for. So that's a character that's set in the sense of a vertical strip in our model. Digit or number, that's kind of self-evident what that is. It adds some aliases, so you could use digit, you could use number. Anything. That's kind of what it means. It means anything except a new line. So match any character except a new line. And there's its opposite, new line, white space. Space, tab, some weird ones like, well, there's new line, there's return, there's some ones that you would use in line printers or teletypes, but they're still in there. And I should note, Python works with UTF-8, which is nice, but it lets you work with ASCII, which is what all Python's keywords are defined in. So people, it's kind of neat because people from other countries can write Python code, and when you read it, they use identifiers that make sense to them, and their comments can have all the umlauts and accents and whatnot, and it's fine. So let's get down to it. Raw is a way to do what I did with Python. Okay, quantifiers is like the next class it goes to. So sometimes you want a match to occur once, or you want to occur some number. So you use the keyword exactly 2 times. Yeah, well, and then the short, once it's kind of a case they gave you, or twice, or you would specify a number of times that it would match for that quantifier. So you can do between 3 and 5. So anything less than 3 matches of your sub-expression would cause it to fail and go searching for it. Or anything over would also cause it to fail. Well, it would cause it to fail if the next term, didn't work. Was an extra term beyond the y time. This is interesting. Once or more, never or more. These are 2 instances, and they use their own special characters, vary from language, regular expression language to language. Once or more, in Python, we use a plus sign. Never or more, we use an asterisk, and it modifies the letter that we're searching for or sub-expressions. Okay, like I said, I wasn't going to get through everything, and I didn't, but this is available online. You can run it and play with it and have a lot of fun. Okay, so that's the talk. Thank you.